So these are spectra that I recorded in 1968. So
what's the nucleus?
Pardon?
Yeah, what's the nucleus for?
Oh, proton. It was only proton. It was done on a 60 megahertz HA60. So this is a variant instrument. It's a continuous wave instrument, and this is the spectrum of this benzaldehyde derivative.
Hello everyone, I'm Mojtaba and welcome to another episode of A Sip of Chemistry. Rod Wasylishen, an NMR scientist well known in the field of magnetic resonance spectroscopy, is our guest today. With over 50 years of experience in the field of resonance spectroscopy, he has made significant contributions to the research community. I had the opportunity to spend a day with him and talk about everything from NMR spectroscopy to personal aspect of his life. I asked him questions about the development of NMR throughout his research journey, his opinion about the future of NMR, and many other interesting questions. I wish I could capture everything on film and share it with you. It's truly my honor to invite you to watch the interview I did with Professor Rod Wasylishen. Thank you, Professor. Thank you so much for agreeing doing this interview. I'm so glad that I'm here in person in your office in University of Alberta. So before I ask about your academic background, I would love to hear about the lab that you set up at your parents' basement. Would you tell us that story in your high school?
My first class in chemistry was in grade 10. And we had a teacher who came in and used phenolphthalein to show us what happens when you have an acid versus a base. Yeah. And I was so impressed with the color going from clear to this brilliant pink color, something like this.
Yeah.
I really wanted to understand what was going on, what's happening here, why does this happen, and so that's what really got me intrigued with chemistry.
Yeah,
it is trying to understand, what's happening here, what's going on in solution. And so I was fortunate. There were 2 pharmacies in the town that I lived in, small town, 2,500 people roughly. And the pharmacist there, one of them I knew quite well, who encouraged me, with chemistry, to do chemistry. But later recommended that I don't study chemistry at university, or pharmacy anyway. Mm-hmm. No, he didn't say don't study chemistry. So I got this little handbook here. It was from some sort of a store that specialized in
amazing.
People that had hobbies, and one of the hobbies, was this, I guess, for young people, handy chemistry, world of chemistry.
So what is it about, this book?
This book, it's got all these little experiments, right, that you can do. So you can, it tells you that everything is safe. which is kind of a joke. So chemistry of hydrogen. So it tells you how to make hydrogen, how to make ammonia, and so I did these sorts of things, and I just had one little corner in the basement that my parents didn't mind me playing around with, but it did cause some problems when I had the odd explosion.
Oh, really? Explosion?
with with hydrogen.
Oh, yeah.
And I was really fortunate that I didn't lose a hand or an eye or something. But it really I found it intriguing, and that's how I got started. And as I said, my parents
were very serious, and you really were into chemistry. Yeah.
I used to ask the teachers questions, and I didn't get answers because they just didn't have the background, and that's why they did these. They allowed us, I guess, to do the things because they didn't really understand the danger or long-term effects. I always used to say that shielding and charge are completely, they're not related. Magnetic shielding is not related to electron charge, and I gave several lectures about that's not the case. And then they put down here REW, shielding and charge related. And then they have, this is Cynthia Jameson, skeptical. And they have all these stupid, Tourist Bush and Esther's bars. Anyway, just crazy stuff, right?
So, please tell us about your education and academic background.
Well, excuse me. I started out in rural Alberta. In grade 1, I was in a one-room school. We moved to Edmonton for 1 year, so I did grade 2 in Edmonton, which was quite a shock after I had been in a one-room school where we had grades 1 to 9 in one room. And my parents didn't like living in Edmonton, my dad in particular, so we went back to a smaller town. And they had a 2-room school, so I had grade 1 to 4, grade 5, I can't remember, in one room, and I was there for grades 3 to 6 inclusive, and then we moved to Vermilion, a larger town where the population was around 2,500, and we had one class for. One room for, actually we had 2 rooms for grade 7s because many students were bused in to attend the school. So I did get some, a decent education there. But I was most interested in math and later chemistry and physics. I was not. And I did very well at math, but I didn't do so well in some of the other subjects, and I wasn't sure what I would do after. Most of the students that I went to school with in high school were, their parents were farmers, so the students would go back and work on the farm or do something like that. So very few students went to university. And I decided, I wasn't sure what I would do. My dad said, he would help me for a couple of years. So I decided to go to the Southern Alberta Institute of Technology and take it was a laboratory technology program for 2 years. And I really enjoyed that. And after my first year, I did very well, and they put me in a special class. There were 15 of us in this class. And after that, I got a job at Atomic Energy in Pinawa, which they were just building the reactor, a nuclear reactor there. And they had engineers from the University of Waterloo that were on work terms, and one person in particular, I told him I wanted to go on to university at some point, and he said, well, you should go to Waterloo. And I said, well, I was going to wait. I think I'll work a year. And then I decided, or he sort of convinced me that, I should go to Waterloo now, right? So I just spent about 4 months at Atomic Energy of Canada in Pinawa and moved to Waterloo, and I started doing honors chemistry there.
Okay.
And I was there for 4 years.
So,
And I was introduced to NMR in my third year. Well, after I finished the third year, Waterloo had just got money to buy a 60 megahertz spectrometer, a GL, and Terry Goff of the NMR, and was great. It hired me to work with him in the summer, actually to synthesize metacyclophane, which I did. Probably took me a month. And then he was interested in ESR, electron spin resonance. And so the experiment that we wanted, I won't go into the detail, but it was basically making a radical and having the electron hop between the two rings.
Yeah.
And this had been observed in paracyclophane, but not meta. Well, it didn't actually work out. But that was my introduction to NMR. And then, the summer was over basically. And then in our final year at Waterloo, we had to work with 3 different professors. So I worked with the theoretician and he had me write a Fortran program to do the harmonic oscillator. So I worked through the harmonic oscillator, did nice CalComp plots of the energy levels, the vibrational energy levels, and so on and so forth. And then the second one I did was with Terry Goff, and again it was NMR, and I have those were the first spectra that I did.
Oh,
and they were AA prime, BB prime spectra, and not done on this paper here.
yeah.
High resolution spectra, and there was a program called Laocoon 3, which he had got from somewhere. I don't know where he got it from, and he had me get it going at Waterloo. So I did, because I had done some computer science and was very interested in this. So I got the program going, and I've got some of the output files here, but I won't bother showing them to you. But so when I finished at Waterloo, I wanted to do graduate work, and most of my friends said, "You're crazy to do graduate work because you'll never get a job." But I said I want to do NMR, and the obvious place there were 2 places to apply. I felt, and I decided to go to the University of Manitoba because Ted Schaefer was there, and he was a young man at the time. He had done his Ph.D. at Oxford and had published some of the first NMR, high resolution NMR spectra, and had also worked at NRC in the summers with Bill Schneider. And
so that was the best place to start learning NMR at the time.
It was the best place, and there were a couple other people there that were ahead of me who had done well after studying at the University of Manitoba, and that's where I went. Of the encyclopedia, this was done by David Grant and Robin Harris. And this historic perspective part is just, it's outstanding. And a tremendous amount of time was spent by Ted Becker, who was my postdoc supervisor. So Edwin Becker. Robin Harris asked me if I would be willing to serve as an editor, associate editor with him on the next version of the encyclopedia. And this was published in 2012. And again, a lot of work, a tremendous amount of work was put into this. And it was given a slightly different name. But again, we requested updates from some of the original ones, and then there were a lot of new people that were working in the field. So we asked them to contribute.
What was your first experience with NMR?
Well, the first experience, as I said, was at the University of Waterloo. Yeah. And it was a GL 60 megahertz. And
so when you joined Ted Schaefer's lab, he handed you a cardboard box.
Oh, yeah.
What was that story about?
When I first went to Manitoba, I had graduated from Waterloo, and I was driving back to Alberta because my parents lived in Alberta, and I stopped at Manitoba at the U of M to visit Schaefer. I'd never met him or talked to him actually before. Mm. And he was off to spend the summer at Argonne in Chicago, and he said he sort of gave me a rundown of who was going to be looking after the lab, and said that he wanted me to look at solvent effects, basically obtaining spectra in cyclohexane and of some simple aromatic compounds, and compare those with the results when you obtain the spectra in benzene.
Yeah.
So I was basically looking at solvent effects on chemical shifts.
Yeah. And
it took me probably most of the summer to figure out what I was doing or what to do. And I talked to him on the phone a couple of times when he was in Argonne. And he was always encouraging, but he never actually told me what to do. When he came back in late August or September, I said to him, I'd like to look at some systematic trends, right? And I'll start with some 2,6-dichlorobenzenes, and I'll put different substituents on there and look at solvent effects. And I said, can I order some of these chemicals? He said, sure, order whatever you want, So, but he never told me what to do, right? He just so that was. It took me 2 years to get my master's.
Okay.
And I spent a lot of time. And as soon as he got back, he sort of took me by the hand and got me to do one simple experiment. Well, it was measuring the signs of using the Fortran program to actually show how the spectra depended on the sign, and that was sort of my first paper, right? So he was very encouraging, very helpful, but never really told me what to do in general, which
gave you the freedom to do what you would like to do.
I could do more or less what I wanted. I mean, I stuck very close to benzenes, and because he had benzene all kinds of benzene samples, and
Yeah.
and there were lots of different things that we were interested in: high resolution spectra, measuring long range coupling constants, and again, at the same time, Popel had come out with the CNDO and INDO, and I wanted to get those programs going, and I did. And you could get the actual program from this quantum chemistry exchange, but it didn't have the NMR part in it. So I spent better part of the summer putting in the part to calculate coupling constants.
So you back then you did a great job in calculation also, yeah?
I did a lot of calculations. So quite a few of my papers were strictly on computations.
So please walk us through the development of NMR within the past 50 years.
50 years.
Yeah, you have seen many instruments.
Well, I guess I won't go back before I started doing NMR, but the spectrometers when I first started were the largest ones that we had available in Canada were 60 megahertz, at least at Waterloo and at the University of Manitoba. And the largest ones were 100 megahertz. There were no superconducting magnets when I first started. So it was all continuous wave, mostly proton NMR, very tedious instruments to operate most of the time, but well, we could do a lot of things. But when with continuous wave instruments, you couldn't really measure relaxation times very easily. Very difficult to do. A lot of things that we take for granted. Shimming, of course, took time. And of course, you know, these electromagnets, they had to have water running through the magnet all the time. So tremendous amount of water being used at the U of M. And of course, you know, in the summer when it was hot, the water would have worms, little wildlife in it, right? And some of the filters would get plugged, and sometimes we had to shut the magnet down and clean things up.
Instead of cryogens, you use the water, to cool down the magnet.
Yeah, they're all electromagnets, and so the water ran through the poles.
Okay.
Yeah, so that's how it started. But then Canada actually got a 220 megahertz spectrometer outside of Toronto, and I'm not sure of the details who paid for it, and it was sort of meant to be a workplace for everyone, but you know, and it was CW, and again, we didn't use it. We had enough. Ted, while I was at Manitoba, we got 100 megahertz. So that was a big improvement from 60. And so I guess the last half of the year, the last year I was there, maybe the year and a half, I did a lot of my research on the 100 megahertz, which was really nice. And then you know, Schaefer sent me to a workshop that was at the University of Waterloo, actually. And I heard Ted Becker speak about NMR and developments there, and they had a 220 megahertz. And I thought, well, for a postdoc, I'd either work with David Grant or Ted Becker. And David Grant was at Salt Lake City in Utah, and Ted Becker was at NIH in Bethesda, Maryland. And I actually, I have to say that David Grant actually called me and said, my lab is full. I think you're better off going, to Ted Becker's lab. So I went to Ted Becker's lab. I got to Ted Becker's lab, and they told me, well, you can use the spectrometer Sunday nights, maybe the odd Saturday, but be prepared to work at night. And I said, fine, that's all right. I'll work at night. But it was a fantastic experience to work at NIH and meet some people that were really that were doing bio research, and I worked with a guy called Jack Cohen.
Yeah.
And we published a paper together in Nature on relaxation in biomolecules, mostly molecules that contained histidines. So at that time, FT NMR was just starting, and then it was in 1972, and Varian came out with this so-called CFT20, which was 80 megahertz for protons, 20 megahertz for carbon. Mm-hmm. And they actually came to NIH in a van, and they had the spectrometer on the van, and they would hook up. It was an electromagnet, so they would hook up to a water system. They did it at NIH, and you could go out and actually use the spectrometer just to see how easy it was to use the spectrometer. And so when I was finishing up my postdoc, I heard that the University of Winnipeg was looking for someone, and they had got money to buy a CFT20, a Varian CFT20, and that was, FT, carbon NMR. It didn't have proton when I first got there.
Yeah.
And so I was really happy to get the job at the University of Winnipeg. I had applied to every university, I think, in Canada. Yeah. And I had maybe one interview, or I actually had offers after I accepted the one in Winnipeg. I actually had a request to go to Dalhousie, and I had already accepted at Winnipeg, and it turned out sort of accidentally 10 years later I ended up at Dalhousie. But anyway, so at that time in Winnipeg, FT, the U of M got a Brooker 90, and it was Fourier transform. And I got protons on the CFT20, and then started doing work on solids, orientationally disordered solids, so-called plastic crystals, and we looked at adamantine, for example. And in the physics department at the University of Winnipeg, they had a spectrometer where you could do solids, and I was lucky enough to get permission to use that spectrometer occasionally, and I did. I decided to go on sabbatical after being at Winnipeg for 7 years, I guess.
Yeah.
And I went to the University of Guelph to work there, and with Colin Fife, a Scotchman, who was really outstanding. He was doing a lot of solids, and I guess I would sit at that in front of that spectrometer. It was a Brooker 90, and we had a probe to do magic angle spinning, one of the ones that Colin had actually developed himself. He had spent time at IBM before I came to Guelph. I don't know off the top of my head, but I was there for a full year, and I was there as long as I possibly could be away from Winnipeg.
Yeah.
And I think I got something like 12 papers. I mean, I sat in front of the spectrometer every day, most of my sabbatical. I spent a lot of time, and Colin was writing papers, and I was collecting results, and it was something else.
Awesome.
And then I went back to Winnipeg for a year, and then I went to Dalhousie. And so while I was at Guelph, they got a 400 megahertz instrument specifically for the region. It was for the southwestern Ontario.
Okay.
And it was a regional center. And I got time on that spectrometer. So there were times where I was running both spectrometers on weekends and and at night. And yeah, I mean, it was, so again, I as I said, I got a lot done. Also, in the physics department, I was able to do some work there with a guy called Ken Jeffrey, who did nothing but solids. And so we published, I don't know, several papers as well. So it was a very productive sabbatical, and I learned a lot about solids. And so when I got to Dalhousie, I wanted to do solids. And we had solids capabilities on this Nicolay 360 that they got. It arrived shortly after I got there. And then I got money for the MSL 200. And so solids really took off, around in the early 1980s. Mm-hmm. And, the instruments became available just dedicated for solids, commercial instruments. Yeah. And the Brooker MSL 200 was one of the first, which I had. So from there, I guess we went from, there was really nothing much more than 400s. There probably some 600 started, becoming present. Maybe at I forget the statistics, but early on, U of T would have had a 600 UBC. Here they got a 600 in the 1980s. I can't remember exactly when. So there were a few 600s.
So 80s, late 80s or mid 80s, high field NMR became available across.
Yeah, it became available across the country. All of the bigger universities would have had a superconducting magnet of some sort.
Yeah.
And 400s. Well, like I said, when in 1981 or 81, when I was at Guelph, they got a regional center for a 400, and so that was the first 400 in all of southern Ontario. And then, of course, within 5 years, there were more 400s and eventually, 600s. So that sort of, and then I guess I don't know if there were 800s. I don't think there was really nothing above 600s. And this is when we started thinking about. We actually thought of trying to get 2 800s from CFI. When the CFI came out, you could buy 2 800s for the price of a 900. So we decided, after some discussion, to actually go for a 900 instead of 2 800s. And that was a very smart move. And I'll just mention that when we went to defend our choice, the first question I was asked was, why aren't you asking for 1 gigahertz?
Mm-hmm.
And there was no 1 gigahertz available at the time. 900 was the largest.
Yeah.
Anyway, it was something I'll never forget, somebody asking me. So it was a good thing we didn't go there asking for 2 800s, because they would have said, well, what's wrong with you guys? You should. Well, I mean, this was the first spectrometer at the U of A, 61. So this was sort of a workhorse instrument where, the first real NMR that, organic chemists could use, or, almost anyone could use. It was very simple. And, well, you can see all of the different things that you could adjust: RF field, Y gradient. So that's to do the shimming, bandwidth integral. I mean, I used the thing, I used these. They had one at the University of Manitoba, on the 5th floor.
Oh yeah.
And as I said, the inorganic or chemists that used it always complained said, the resolution was crappy. And I went up there and spent a couple evenings, and I could get the line widths down to 0.15 or something hertz.
So you have done in terms of research, you have done quite a wide range of applications and sensitivity enhancement, porous material investigation of soil organic matters, all these things in using NMR spectroscopy.
Yeah.
I would love to know which one is your most favorite research topic.
I guess the biggest thing was the quadrupolar nuclei. I don't think it was recognized by the general, by chemists in general, how the advantages of using high fields to look at quadrupolar nuclei, and things that we could do on the 900 that were simply impossible to do on a 400, certainly impossible on a 200. So the using high fields to examine quadrupolar nuclei, the gains are amazing, and much more so than in doing spin 1/2 nuclei. So I really was impressed and hooked on trying to show that you could do great things with quadrupolar nuclei.
What has been the strangest material that you put in the magnet?
Oh, the strangest material I put in the well, I don't know if I should say much about that. I mean, I worked with a biologist at the University of Winnipeg, and she was interested in tapeworms, and so we did some work on tapeworms. I did put the odd caterpillar into a magnet and acquired the C13 NMR spectra.
Yeah, you have received so many awards, and last year there was a symposium in honoring you in solid state NMR. So would you talk about that symposium and your feeling about being honored?
Well, I'm very grateful for, again, it wasn't really me, it was all of the students, the other professors that I've worked with at the U of A, at Dalhousie, at Winnipeg. It's not, these awards don't come just from one person. It's it's something that happens maybe because you're anxious to help other people, or maybe they're trying to help you. I don't know, but anyway, I can't say enough about the incredible grad students, postdocs, people that I've been privileged to work with, and it's not. Those awards are not simply my awards. They're awards of the great students and colleagues that I've been able to work with over the years. Yeah, it would come out every month. So this is October 1975. So you had to write a letter about what you're doing. So here's Schaefer. This is not Ted Schaefer, and Stetsko. Okay, so what are they doing? Carbon 13 NMR at the magic angle, right?
Did you send anything to?
Oh yeah, I was just going to see. I'm sure that we can find one if you want to see. Hand. Oh yeah, there you go. Proton and C13 NMR of nitrobenzene N15.
Rod Wasylishen, yeah.
Page 57. Let's see what I have. I don't even remember what I. Oh, there you go. There. This is a high resolution spectrum. Everything's coupled to everything. The N15 couples to the protons, and the protons couple to one another. And there's all the coupling constants. Dear Barry.
Yeah, interesting.
I'm presently writing a review for annual reports in NMR. C13X, nuclear spin coupling constants, where X is the first row element. July. I wrote this the day before my birthday. Birthday's on July 6th.
Amazing.
University of Winnipeg.
So, is there any research topic in NMR you didn't have the time or opportunity to work on it, but you would like to?
Oh, I'm getting a bit too old for that question. Right now I'm doing a lot of computations. I wish I had more time to go back and learn more about the theory. But experimentally, obviously, it would be nice to do DNP. There's some experiments that I would like, some low temperature experiments that I'd like to do just CW or FT NMR on, and I still hope to do a few things, but most of them are difficult to do because they're samples that I wanted to do at low temperatures.
Yeah, you have done quite great works. Yeah.
Well, thanks. Yeah.
What do you think? What should be the future of NMR, or how do you see the future?
When we had iron magnets, we thought 100 megahertz was sort of the end, right?
Yeah.
And then then all of a sudden there's superconducting magnets.
Yeah.
Then you could do things with superconducting magnets. So how high can you go with superconducting magnets? Well, maybe 1.2 gigahertz is sort of what the limit is now. But they do have, this magnet that I don't know, it consumes a tremendous amount of electricity, like about 1/5 of the electricity of Tallahassee.
Yeah.
And you never know what materials are going to come around, and maybe we'll be able to do, or maybe people will be able to work at instead of working almost in the infrared region. I mean, who knows? So I mean, if you look at what is happening now, one of the things I've noticed is that more people are looking at using NMR at low fields,
Mm-hmm.
and in particularly, there was an article not long ago in Science, I believe, about manufacturing MRI instruments that are portable, you know,
Yeah.
and instruments. Well, I mean, there is a lot of magnets now where, you know, you can put the NMR spectrometer in a fume hood and operate at 60 megahertz.
Yeah, interesting.
You know, so this is the kind of thing where I see applications of NMR if they can get the price down and I don't know. I think the spectrometers will become easier to use, more of them. There's so many interesting experiments that you can do. Okay, in the summer, I had a student and working. We were working with stereoisomers, and you know, you in when I first was in doing NMR, of course, you couldn't separate stereoisomers. Now you can do techniques and get the spectrum of the other one, completely separated. So there's all kinds of new experiments that you know, we would have never imagined that are routine.
Yeah.
So I don't know. I mean, I don't know if that is finished or if it's still evolving. I mean, it may be evolving. I don't know, but certainly, you know, it's more geared now for biomolecules, looking at proteins, rather than, you know, the simple organic, you know, under 1,000 molecular weight. Those things are routine. I don't know how much more they can do. They can probably improve the sensitivity.
Mm-hmm.
But as far as the tricks, I don't know if they're finished or not. You know.
Yeah.
I would say that it peaked some time ago.
Mm-hmm. Okay. Interesting. So let's talk about something other than NMR. So
Sure.
what's your hobby? What do you do in your spare time?
Well, I'm fortunate. Two of my colleagues at the U of Alberta, I got them actually interested in running, and we during the pandemic in 2020, I think we ran. I think we ran over over 2,000 kilometers.
2,000 kilometers.
2,000 kilometers. So we ran almost every day. So I enjoy running. I'm still running 25 kilometers a week, maybe more.
Yeah,
some
that's
weeks.
a lot.
And what else? I did some swimming, but I guess my favorite. I really enjoy hiking. I like to go hiking, especially with my son. My youngest son enjoys hiking as well, so we make a lot of trips to the mountains, or when we can. I was always interested in astronomy. I have several telescopes. The problem is now that the bigger telescopes are difficult for me to lift and handle. The other thing is the light pollution in and around Edmonton is really terrible. So you have to drive for an hour to get away from the lights if you're interested in astronomy, or at least it's desirable. One of the things that you may not know, but I was always interested in interstellar molecules, and I've sort of been keeping track of the various molecules that have been identified, and this is something that continues. I try and follow some of the astronomy literature and listen to some of the American Physical Society has a group that, and the students often are giving seminars, and I often listen to them talk about what they're doing, and it's really quite amazing. And I guess I'm still interested in detecting molecules using microwaves, microwave spectroscopy. So it's amazing what's going on in astronomy and the number of molecules.
Yeah, interesting. Yeah, that's amazing. So another question that I would love to ask is, in an imaginary world, another world, what's your job?
Well, my job, yeah. As I said, I've always enjoyed the outdoors, so maybe it would be interesting to work in some national park. But again, those jobs are changing all the time. So I can't predict what I'm doing tomorrow, let alone what I would like to do in another life. I mean, maybe it would be nice to go back about 1,000 years or 500 years.
Yeah, that was the next question I wanted to ask. Do you like to travel? If you could travel in time, you go to the future or to the past?
I can say that I've been very fortunate to be alive when I lived this last 80 years the way I have. It's been really a good time to be alive, and a good time for everything. Medicine is medicine's improved. Everything's improved a lot, and our life is a lot easier than it was, I think. Well, for some of us anyway, maybe not for everyone, but I would say it's been a good time overall.
Thank you so much. Thank
Okay.
you for your time, and
you're welcome.
I'm so happy and so glad that you let me do this interview. Thank you.
Good, thanks. It was nice meeting you.